Hello everyone. Welcome to BellaDati Machine Learning Overview. The video is divided into two parts: Introduction to the BellaDati Machine Learning Studio and the live demonstration. Theoretically, machine learning is a process of creating and running predictive models from existing training data in order to predict values and behavior or to explore trends. For this purpose, BellaDati would like to introduce the Machine Learning Studio, which is an integrated part of the BellaDati platform and framework. It is used for developing and running situational intelligence applications. It can run various applications and has an interface to data sources and analytical models. Besides this, it is a framework for users to interact with data and analytical results. BellaDati Machine Learning Studio offers access to BellaDati pre-configured packages and BellaDati domain-specific language, which means there are ready-made functions which you can use directly inside the studio. You don't need to think about the regression models, statistics, or summaries of the files. You can simply select them inside the code builder. It is also possible to create your own packages, define the parameters, or allow users to select files, datasets, or data sources directly from the project. Users have access to various Java libraries, such as Java Machine Learning, Apache Commons Math3, or Java Stat. Very important to say is that it also supports Python, R, and their libraries, and the scripts can be executed directly from the studio. The whole solution can be stored in a package and distributed. We are distinguishing two basic building blocks: project and pipeline. There are a couple of differences between these two blocks. The project defines the execution script and the algorithm. It works with data structures and objects which are accessible within BellaDati, such as datasets, data sources, or reports. Projects also have their own intermediate storage, which means it is possible to store data between the stages. There are various options on how to run the project. The project can be executed on demand directly from the Machine Learning Studio. The execution can also be scheduled to run automatically or after every data change event. Lastly, the execution can be triggered through the REST API. The second building block is the pipeline. The pipeline is a sequence of two or more projects. It is using the projects as parameterized building blocks. Once a project is defined, it can be stored in a package, and then the users are able to use it in their pipelines without the need to touch the code or the algorithm itself. They just need to fill in the required parameters. The pipeline is very useful for staging. For example, with more complex pipelines, users can define stages for data extraction, the building of the model, estimation of the results, and saving of the output. The pipeline itself can run in a parallel mode, which means that multiple projects in the same stage are executed at the same time. They can also run on different machines, so if you need to achieve better performance, you can very easily define on which machine the particular stage should be executed. Similar to a project, the execution can be triggered manually, through REST API, or automatically after each data change or at a certain time. Now let's go through the functionality of a project in more details. It has its file storage, and users can also upload and use custom libraries in the project. Each project can contain variables and parameters. If the users do not want to write the code on their own, they can use the code builder to simplify the creation of the algorithm. In the Machine Learning Studio, you can also see the execution history, and you can schedule a new execution. It is also possible to see the result immediately and directly in the studio. Now let's see this all in action. To be able to use Machine Learning Studio, it has to be enabled by the license key. After signing in, users can open the studio by clicking on the link in the top menu. On the home page, all available projects and pipelines are listed. On the left side, you can see quick links to the home page, help, and settings. On the right side of the screen, the execution schedule is displayed with the list of previous and scheduled executions. We will start the live demo with a series of basic examples. We will try to create basic data structures, display the data in tables and charts, and to output the results in the console. So let's create a new project by clicking on the button New Project. We can add a name to the project, e.g., our first project. The project page is divided into multiple areas. From the left menu, we can upload files to the project, activate or deactivate available machine learning libraries, and define various parameters and variables, which are used to enter numerical or textual values. The parameter can also be used for selecting a data set or a file. Lastly, users can open the execution history and easily jump back to a previous version of the project. The bar in the middle contains basic controls. They are used to open the summary of the last run, save the project, or discard the changes done to the code. It is also possible to use the code builder to easily add ready-made parts of the code. Finally, users can immediately run the project or schedule the execution. The most important part is the code editor in the middle, which is used for writing the code. As already mentioned, it supports Java, Groovy, Python, or R. Let's define a simple data structure. We can define an array with these 3 numbers inside. Then, we can take these values and display them in a bar chart. The function bar chart has 2 parameters, the name of the chart and the data. After running the code, a bar chart is displayed on the left side of the screen. We can do the same by using the code builder. We will create a bar chart with the name chart2. We can reference the array which we created previously, or we can define the data directly inside the function. Optionally, it is also possible to define the headers and color. Now, 2 charts are created, and we can switch between them by clicking on the links. The colors can be easily changed by specifying the parameter. All available options are listed in the documentation available online. Together with the charts, we can also create tables. The process is similar. When we start typing the word table, the studio will automatically display all functions which match this word. The table has the same parameters as the chart. The first one is the name of the table, and the second one references the data. After execution, 2 charts and 1 table are listed in the results. It is possible to download the table as a CSV file. Next, let's take a look at how errors are handled in the studio. When you make a mistake or a typo in your code, the system will return an error in the output console, and also a red cross will be displayed, highlighting the error in the code. In our case, there is a null pointer reference. This means that we are trying to reference something which is not existing. The console can be used to display other outputs as well. For example, if we want to see how the execution has been processed, then we can add some outputs to the console to track how the code was executed. Our second example is focused on uploading a simple file to the Machine Learning Studio and getting a summary of the data. At the end, we will try to visualize the data in a temporary table. Let's start by creating a new project. We can name it Example 2. The next step is uploading a file from the file system. In this case, we will import data about telco customers. In order to get the data, you can either use the autocomplete function or use the code builder where you can just select the file and the code is automatically generated. Inside the execution body, we can find references to the rows, volumes, columns, and indexes. We can try to print the values from the file to the console. As the next step, we will store the values inside the data structure and display them in a table. In this case, we will use an array list. The process is very simple. We will just add the values to the list and then add the list to a table. The name of the function is table. The first parameter is the name, and the second parameter is the data structure which should be displayed. After executing, the table is displayed in the right sidebar. We can use the pagination at the bottom to see all rows. Another advantage of BellaDati Machine Learning Studio is the option to use library BD-stat for easy data analysis. This library contains a function which is called summary. The only thing which we need to do is to copy the function for reading the data file and paste it as a parameter to the summary function. The data will be read from the file and analyzed using the BD-stat summary function. Again, the results will be displayed on the right side of the screen. We have a new table which is containing the output of the function. The first column contains the name of the variable. Other columns contain the most important values for each variable: minimum, maximum, mean, median, and quartiles. You can resize the layout to get a better view of the table. Let's save the project and jump to the last file reading example, which is focused on parameters. We can add a new parameter to the project by using the button on the left side of the screen. In this case, we will create a file parameter. We can reference this parameter with the character @ followed by the code of the parameter. Now, before executing the project, the user is prompted to enter the file. This feature is especially helpful when you are creating a package which will be parameterized, as the end users will have to select the right file and click on Run. The third machine learning project will be about reading data from a dataset and building a regression model on top of the data. As the last step, we will visualize the results. We can use the code builder to add the function for reading a dataset. We need to select the correct dataset which we would like to analyze. If we take a look at the dataset itself, we can see that it contains information about telco customers. We can see their age, gender, and what kind of services they are using. The code builder will automatically create the code. Let's define a couple of structures. We will work with the columns and with rows containing numerical data. Inside the execution body, we will just set the columns to the current columns and then add the rows with an index greater than 0. We want to exclude the first row, which contains the header. Then we can add the values to the rows. We are working with numbers, so we need to convert them because they are coming as text values. We will copy the code and use it for each column. As the next step, we can build the regression model. It will be represented as a matrix of numbers. We need to fill the matrix with the number which we got from the previous step. For this particular case, we will use the Pearson correlation. We will pass the matrix as a parameter to the function. We can store the results in a temporary table by using the function getData. Let's see the results. In the table, we can see the correlation between all the services. In the next project, we will take a look at how to work with Python inside the Machine Learning Studio. Specifically, we will try to pass the data to the Python code and then collect and visualize the results. The first step is to create a new project. We can name it Example 4. Next, we need to define the Python script and store it as a variable. In order to do that, we can just paste an already existing script. In our case, the Python script is creating a regression model and trying to find some predictions. We are using the trained data to build the model and then the testing data to get the predictions. To execute the Python script, we need to use function execute_python. This function has two parameters. The first one is the variable with the script itself, and the second one is the file which we want to use as the input. We will build a data stream from this file and pass it to the Python script. In order to create a stream out of the file, we will use function stream_csv_file. To read the file correctly, we need to specify the value separator, which in this case is a comma. As the script is now ready, we can try to run it to see the results. We can see the final results in the temporary table and also the interim results directly in the console. The next step is to store the data in a dataset. We already have an existing dataset which contains attributes broken and ID, and also an indicator where the remaining lifetime will be stored. We need to copy the ID of the dataset and use it as the first parameter of a function storeDataset. The second parameter is the input. In this case, we will create a stream from the temporary table. And the last parameter is the mapping between the result and the columns in the dataset. After successful execution of the script, we can see that the data are stored both in the temporary table and in the dataset. When working with R language, the approach is almost the same as with Python. The script is stored in a variable and then executed with function execute_r. More details can be found in our documentation. The last part of this video is about pipelines. As already stated, the pipeline is a sequence of two or more projects. Each pipeline is divided into stages, and each stage contains at least one project. Projects in one stage can be executed in parallel. This is especially handy for more complex algorithms. For example, the first stage can be used for loading data from a third-party database. Once this stage is done, the execution will continue with the next stage, which can be used for processing. The values can be also transferred from one stage to another. The last stage can be used to store the final results in a dataset or to send them to a different third-party tool. If the project has parameters, users can set their values directly from the pipeline. As the last step, users need to choose how to execute the pipeline. They can choose to run it manually, schedule the execution, or enable the data change trigger. In that case, the pipeline will be executed after every change in the selected data set. The Machine Learning Studio is a powerful tool which allows you to easily create more complex analytical projects, thanks to its integration with the whole BellaDati platform. Thank you for watching.